Hello student, welcome to chemistry class with Emerald. This class is a continuation of our class on preparing standard solution, and in this part B we are going to be looking at how to prepare standard solution of acids and base. We have looked at before what are standard solution, primary standard, stock solution. We have looked at normality and molarity, and how to calculate normality and molarity. In this video, we are going to look at how to prepare standard solutions of acids like H2SO4, HNO3, H3PO4, and base like sodium hydroxide. Some of the materials we are going to need to prepare these substances are, we are going to need a graduated cylinder, or what we call a measuring cylinder, for the purpose of other experiment that you may want to perform. Depending on whatever is required for you to use, you can use 100 ml, 50 ml, 200 ml and the likes. But the ones that you see here are specific to the ones we want to prepare. But your graduated cylinder or your cylinder can be of any volume, as the case may be. So you are going to also need a standard flask to prepare standard solution. You need measuring cylinder. Measuring cylinder is usually used to measure liquids, especially the acids that you want to use. You have a volumetric flask, or what is called a standard flask. You are going to need a beaker. The work of the beaker here is that you, whenever you get a substance, you first transfer it to a beaker before you transfer it to a standard flask. You are going to need a watch glass. A watch glass is specifically used to collect the base, because they are usually coming in solids, or what is called pellets. You are going to need a stirring rod or a glass rod so as to mix the solution when you dissolve them in water, so as to obtain a uniform solution. You are going to need a pipette when it requires that you pipette some amount of acid or liquid, as the case may be. You will need an aspirator, or sometimes you can also need a spatula to take the you need it to take the measurement of the base, which is in solid form. You will need an empty reagent bottle. You are going to need an empty reagent bottle, and the reagent bottle is generally to house or take the prepared standard solution. An alternative to aspirator will be dropper. You can use dropper to measure some amount of water or liquid that you want to use. You also need a chemical balance, preferably a digital chemical balance, so that you can use it to weigh the mass of the pellets or the solids, especially in the cases for base. So these are some of the materials we are going to be using. So let's look at preparation of the standard solutions. These are the chemicals that you're going to need. You are going to need your acids, conc HNO3, conc H2SO4. They are both strong acids. You will need conc H3PO4 is a weak acid, so it's also a strong acid rather. And then you are going to need sodium hydroxide pellet. You will need distilled water. So let's go to how to prepare a standard solution. The first one says prepare 3 molar 100 centimeter cube HNO3 solution using concentrated HNO3, and then you are given the normality to be 15.6. It is 15.6 normal. Please take note of that. Now, for you to be able to prepare this very well, you need to know how to use the dilution formula. The dilution formula is a mathematical approach to help us know what amount of water is needed to be added to dilute a particular concentrated solution. So you are going to be using the formula of M1V1 is equal to M2V2, where M1 is the initial concentration or molarity of the acid, V1 is initial volume, M2 is the final volume that you are expected to prepare, the final concentration you are expected to prepare rather, while V2 is the final volume you are expected to use. Now, if you go back to the question says 3 molar. So the final one is 3 molar because you have to prepare 3 molar. So that's your M2 is 3 molar, and then your V2 is 100 centimeter cube. Now you are to use conc H2SO4 that is 15.6 normal, and then in the last video we mentioned that normality is equal to molarity multiplied by molarity is equal to normality times basicity. Therefore, if you want to find the molarity, now you just multiply the normality times the basicity of the acid. Now, to get the molarity of this, now we can say normality, which is 15.6, times basicity of HNO3 is 1, because you are going to have H plus and NO3 minus, so the basicity is 1. So that means we are using 15.6 times 1, as the case may be. So that's 15.6. So the molarity of HNO3 there is 15.6. That's what we are having here. So the M1 is 15.6, but the V1 is not known. The M2 is 3 and the V2 is 100. By the time you calculate it, you are going to have 90.2 mil of conc HNO3. 90.2 mil of mil is equivalent to centimeter cube. So you can also say 90.2 centimeter cube of HNO3. That's the volume we want to use. That's the volume of conc HNO3 that we want to use. So the volume of conc HNO3 is 90.2 mil or 90.2 centimeter cube. Now, because it must be equivalent to 100. So if we are using 90.2 mil of conc HNO3, if you minus it from 100, you are going to have 80.8 mil. You are going to have 80.8 mil. So the volume of water that is needed to make it up to 100 mil is 80.8 mil. So volume of conc HNO3 is 90.2. Volume of water is 80.8 mil. Of course, the molecular mass of HNO3 is 63 grams per mole. Those are additional information that you may want to add. And then the mole of solute is 0.3, and of course you only get the mole of solute from concentration is equal to number of moles over volume. Now, once you have calculated successfully the amount you need, both the amount of water that is needed and the amount of the acid that is needed. Now, the amount of water needed is 80.8. However, for better accuracy, you may decide to first measure the 80 mil. It will remain 0.8. So you measure 80 mil of H2O. using a graduated cylinder and transfer it to a beaker. That's step one. Then from the beaker, you now transfer it to the volumetry flask. Then you also have you measure 90.23 ml of Conc HNO3 using a pipette. You pipette it into the volumetry flask. 19.23 ml of Conc HNO3. You pipette it you pipette it into the volumetry flask, and then you are still left with 0.8 ml of water. By the time you have done this, of course you can mix them together to have an even distribution, and then to complete it, you just use pipette to measure the 0.8 so that you can reach the mark on the volumetry flask. If you have been able to do that successfully, you have prepared that standard solution that is being required. So the molecular formula of HNO3 is the molecular formula of triazonitrate acid is HNO3. It is a colorless liquid, soluble in water, is highly corrosive, and so on. So from the 19.23 ml of Conc HNO3 and 80.8 ml of water, the solution that we prepare by using dilution method is 3 molar nitric acid solution. So you have been able to prepare 3 molar in 100 centimeter cube. Please take note, the question says 100 centimeter cube. That's why we make it to 100 ml. 100 centimeter cube is equivalent to 100 ml. That's why we make it up to that. There is specific information that was given there. Take note of that. So that's how to prepare that. Now let's look at another one. The question says we should prepare 1.5 molar. We should prepare 1.5 molar in 100 centimeter cube H2SO4 solution using concentrated H2SO4. That is 36% normal. That is 36% normal. Now, again, the one we ought to prepare is 1.5 molar. That's our M2. And then our V2, if you want to dilute, is 100 centimeter cube or 100 ml. Now, since you have been given the normality, from the normality we can get the molarity. We have said that molarity is normality times basicity. We have assigned that our molarity, normality is equal to molarity times basicity. Therefore, molarity is equal to normality divided by basicity. So that means to get the molarity of this, now we are going to divide the normality over the basicity, and then the basicity of H2SO4 is 2, because you are going to have 2H plus SO4 2 minus. Therefore, the molarity will now be the normality divided by basicity, which is 36 over 2, and that will give us 18. If you check very well, we are going to have, if you check very well, that's why we are having 18. That's why we are having 18, because we have divided the normality over the basicity. So the molarity is now 18. That's 36 over 2. That's why we are having that. But the V1 was not given. However, the M2, that's the final molarity or final concentration, was given to be 1.5 multiplied by the volume. That's 100. So by the time you do that, the calculation, your V1 is you will need 8.3 ml of conc H2SO4. 8.3 mil of conc H2SO4. So the volume of conc H2SO4 that is needed is 8.3. For you now to be able to make it up to 100, you now do 100 minus 8.3. 100 minus 8.3 will give us 91.7. So the volume of water needed now is 91.7 mil. 91.7 mil. Then the molecular mass of H2SO4 is 98 gram per mole. And then the mole of the solute will be the concentration all over volume. The concentration all over volume. So after that, you follow the normal procedure that we have highlighted the other time. You are going to measure 91.7 mil of H2SO4 through a graduated cylinder to a beaker, then to the standard flask, and then you pipette 8.3 mil of a conc H2SO4 into the volumetric flask, mix together, and you have prepared that solution. Now this one is quite, you might ask that why is this one different from the other one? Why are we not doing 91.0 mil of H2O, then add 0.7? You can decide to do that as well. There is no add and fast rule to it. You can decide to do 91.0 mil of H2O, then you now add 0.7 mil. Or you can also decide to do it at once, so you can prepare it. Just ensure that you get the quantitative value of whatever you are preparing, so that you don't mess it up. So that's how to prepare the standard solution of H2SO4 using that given information. So if you have done that, you have prepared 1.5 molar in 100 centimeter cube H2SO4. And other properties is of H2SO4, or tetrasulfate-6 acid. The molecular formula is H2SO4. Its appearance is colorless, clear liquid, or slightly yellow, viscous and odorless liquid. It is miscible in water. It is non-flammable but highly corrosive. It has a pungent ethery smell, and it is also soluble in water in our concentration. So the description is also that if you have been able to measure 8.3 ml of conc H2SO4 and 91.7 ml of water, if you are able to measure them and mix them together evenly, the solution we have produced using that dilution method is 1.5 molar sulfuric acid solution. So let's look at another one quickly. Let's look at how we can prepare 0.5 normal. Now in this case, now we are preparing non-molar. Now we are preparing 0.5 normal 100 in 100 centimeter cube H3PO4 solution using concentrated H3PO4 that is 44.4% normal. Now in the other one we have been preparing molar. Now it's very simple. We go back to your dilution factor. Now your normality can also replace your molarity. Take note of that. So you can also say N1V1 is equal to N2V2. Like I've said, the difference between your molarity and normality is the basicity inside there. We have said that your normality is equal to molarity times basicity. So, but in this case that we are using normality, you can still say N1V1 is equal to N2V2. But if it was in normality and you want to now use molarity, that means you still need to convert. You have to divide by the basicity to get the molarity. But in this case, there is no need to divide. We just go straight into the calculation. So you have N1 V1 is equal to N2 V2. For the first one, is 44.4, like we have been doing, is the volume we are looking for. The second one is 0.5 normal multiplied by 100. So that means you need 1.1 ml of H3PO4. 1.1 ml of H3PO4. So the volume of conc H3PO4 you are going to need is 1.1 ml. While the volume of water, because you have to make it up to 100, is 98.9 ml. The molecular mass of H3PO4 is 97.97 gram per mole, and then the mass is 1.64 gram. Then from there you can find the mole. Of course, you know that mole is mass over molar mass. Okay, or you can also use if concentration is equal to N over V, that's the mole will now be equal to concentration times volume, as the case may be. But from here, you should be able to find the mole. Okay, so the procedure is still what we are going to follow, what we have been following. You are going to okay. Now from here, you have you measure 98.9 ml of water through the graduated cylinder to the beaker and then to the volumetric flask. Then you pipette 1.1 ml of H3PO4 to the volumetric flask, and then you mix them together. If you have been able to do that, you have prepared 0.5 normal phosphoric acid solution. 0.5 normal phosphoric acid solution. Okay, so let's look at base. How we can prepare 25% 100 centimeter cube NA solution. We have looked at how to prepare acids generally. But let's look at also how we can also prepare base. Now, to prepare 25% NA solution in 100 centimeter cube volumetric flask, what you are going to need is to get an empty wash glass, and then you are going to weigh 25 grams of sodium hydroxide pellet. Now, well, like we have explained in the last video, 25% sodium hydroxide means 25 grams in 100 grams of water. That's what it means. We have explained that the other time. So that means we are weighing 25 grams, and then to be able to complete it, if we are weighing 25 grams and then we want to make it up to 100, then the mass of water or the volume of water will now be what? 75. So 75 plus 25 will make it up to 100. So that's what you need. So you need 25 grams in 75 ml. So you are going to have an empty watch glass. Then you weigh 25 grams of sodium hydroxide pellet into that empty watch glass, and then you are going to dissolve it in 70 ml of water. You are going to dissolve it in 70 ml of water, and then you transfer it to a beaker. After you are transferring it to the beaker, of course, you know you are going to stir to ensure even distribution. When you stir in the beaker to ensure even distribution, then you transfer it to the volumetric flask. After transferring to a volumetric flask, you stir again. By the time you stir, you now add the 5 ml of distilled water to it. Now the first one, you want to dissolve it. The first 70 ml is to dissolve the 25 grams. The last part, which is the 5 ml, because if you have 25 plus 70, you have 95. It's still remaining 5 ml of water for it to be complete. So the 5 ml of water is to ensure that you make it up to the mark. So you add 5 ml of distilled water to it. With that, you have been able to prepare 25% in 100 centimeter cube volumetric flask. That's what you've been able to prepare. And then for sodium hydroxide, the molecular formula is NaOH. Appearance, it is a white waxy opaque crystal which is odorless. It is miscible in water. It is caustic in nature and readily absorb moisture when exposed to air. Of course, that's deliquescence. It is deliquescent in nature. So if you have been able to use 25 grams of sodium hydroxide and a total of 75 ml of water, the solution you have prepared is 25% sodium hydroxide in 100 centimeter cube volumetric flask. So that's how to prepare a base. That's how to prepare any other base like sodium hydroxide, calcium hydroxide, etc. can be prepared using this, whatever information you have been given. Now, you can repeat procedure 4 that we did for the molality of the solution. You can repeat for the procedure 4. This is how you do it if you are looking for the molality of that solution. Now, let's look at some of the values that we've learned. When you're making chemical solutions, always use the appropriate safety equipment. It is important that you use appropriate safety equipment. Very important. The next one is that, as a general rule, you must always add the more concentrated solution to the less concentrated solution. Take note of that. Add the more concentrated solution to the less concentrated solution. For instance, that of acid, you add concentrated acid to water, not the other way around, not water to acid. So add more concentrated solution to the less concentrated solution. The next one is that you must all the chemicals that you are unfamiliar with should be treated with extreme care and assumed to be highly flammable and toxic, so that you'll be able to prepare for it very well. And that is why your nose mask, your hand glove, your laboratory coat, your glove, your eyeglasses, and everything must be available. Then whatever you have prepared and you have transferred to a reagent bottle, ensure that you label all your prepared acid and base before storing them, and with at least the name, the concentration, the hazard warning, or how the acid can hurt you, and the date prepared. So by the time you are done with preparing, please ensure that whether it is acid or base, whatever any solution you have prepared and you have transferred from the volumetric flask to the reagent bottles, make sure that before storing them, put the name of the acid. For instance, put H2SO4 if it's H2SO4 that you have prepared, and then put the concentration. Maybe you prepared 3 molar H2SO4. You put the hazard or warning sign. For instance, you can put different sign. That means it's hazard. If it can cause fire, you put the fire sign. If you can cause hazard, it can cause a problem to the body, or if it's corrosive, you put the sign, and so on. And finally, in your information, also add the date that you prepare it, so that you are adding the date because over a long period of time, maybe the acid is not being used, and it has reached some time, it may not be needed again. So they need to know the date so that they know if it's still valid, if it's still necessary to be used or not. Some will require that they prepare them freshly. So if the date is there, they can decide on what you. So these are few information that ensue from preparing standard solutions. And then of course, generally now in experiment 1, we have prepared 3 molar HNO3 solution using dilution method, and then we have added 80 ml of water to 90.23 ml of conc HNO3. In experiment 2, we prepared 1.5 molar sulfuric acid by using dilution method, where we added 91.7 ml of water to 8.3 ml of conc H2SO4. In experiment 3, we have prepared 0.5 normal phosphoric acid by using dilution method, where we added 98.9 ml of water to 1.1 ml of conc H3PO4. And in experiment 4, we have also prepared 25% sodium hydroxide in 100 cm3 volumetric flask. So we have, for the first 3, note that we have used the dilution method. In experiment 4, we have prepared 25%. In experiment 4, we have prepared 25% sodium hydroxide solution by dissolving 25 gram sodium hydroxide pellet in 75 ml of distilled water. We did not do the experiment 4. We only did one for sodium hydroxide. So in that of a base, we have used the solubility method, where a amount of substance is dissolved in a given quantity of solute to form a saturated solution. For the acids, we use dilution method. For the base, we use the solubility method. Take note of that. Now, another way to prepare standard solution, apart from the ones that question may come like and ask you that what is the mass of NaOH that is needed to make 750 ml of a 3.00 molar solution? What is the mass of NaOH that is needed to make 750 ml of a 3.00 molar solution? How do you do that? The first thing to do is to convert the concentration of the whatever information that is needed to mass. We want to find the mass first, and in that case we are going to say number of moles, or mole generally is equal to concentration times volume. The concentration will be in molar or mole per dm cube, while the volume will be in dm cube. So that means the first thing to do is to convert the mil to dm cube. Do not forget, mil is equivalent to centimeter cube. 750 mil is the same thing as 750 centimeter cube, and then it's equivalent to 1000 centimeter cube is equivalent to 1 dm cube. So to be able to convert mil to dm cube, you divide by 1000. So 750 over 1000 will give us 0.75 dm cube. So 750 mil is equivalent to 0.75 dm cube. So the concentration there is 3. That's 3 times 0.75, and it will give us 2.25 mole. Then you now convert the mole to mass by multiplying the mole by the molar mass, and the molar mass of NaOH is 40. That's 23 plus 16 plus 1. So 2.25 multiplied by 40 will give us 90. So the mass of NaOH that is needed to make 750 ml of a 3.00 molar solution is 90 gram. To complete the preparation, you can now measure 90 gram of sodium hydroxide pellet using a weighing balance. Of course, you take your watch glass, measure 90 gram of NaOH using a weighing balance to measure it, and then by the time you have measured your 90 gram, you transfer it to a beaker and add some calculated amount of water. You can add 50 ml or 700 ml of water. You can add 700 ml of water to it. Then by the time you add 700 ml of water to it, you stir together, and then you transfer to the volumetric flask. By the time you transfer to the volumetric flask, you are left with 50 ml. With 50 ml of water, you now add that 50 ml until it reaches the mark. So that means you have prepared you have prepared that solution generally. Okay, so you can also prepare acid using this. The question can say you should prepare 0.1 molar H2SO4 in 1 dm cube of volumetric flask. These are slightly different from the ones that we did before. You can also see it in this form, and that's why we are trying to treat it. You have to prepare 0.1 molar H2SO4 in 1 dm cube. The first thing is to also find the mass. How do you find the mass? Mass is mole times molar mass. And the mole is concentration times volume. The concentration given there is 0.1 and the volume given there is in dm cube already. You don't need to convert. 0.1 times 1 will give us 0.1 mole. And then the mass will now be mole, which is 0.1 times molar mass of H2SO4, which is 98. That's 2 times 1 plus 32 plus 16 times 4 will give you 98. So 0.1 times 98, so you need 9.8 gram. After finding the mass, the next thing is to now to find the volume, because acid come in liquid form. So you are going to you are going to find the volume. It is base that you use mass for. So to find the volume, we know that volume is equivalent to the specific gravity of the acid times mass. And in this case, the specific gravity of H2SO4 is 1.84. So the volume is 1.84 times 9.8, which is 18 centimeter cube. So the volume of acid that you need to prepare this is 18 centimeter cube. So you use your measuring cylinder to measure 18 centimeter cube of conc H2SO4 and transfer it and then you can add some amount of water into another beaker and pour the acid into the beaker containing water. Then you can gently stir or mix. Then the resulting solution, you cannot transfer it to a 1000 centimeter cube volumetric flask. Then you continue to add water till it reaches the mark. If you have done that, you have successfully prepared that standard solution. So if you see questions like that, that's how to prepare it. Like we have done initially before, we have used the first set we have used dilution method. The second set we have used solubility method. But in the last two sets that we did, they were different questions, and we have seen how to approach them. Just a reminder of how you do your dilution calculation, so you don't forget. You can use your M1V1 is equal to M2V2. You can also use C1V1 is equal to CFVF, and this is what they mean. So don't forget. So you can, if the question, if you want to solve now, for instance, a question can come like this: water is added to 0.200 liter of a 0.240 mole per liter NH3 cleaning solution until the final volume is 1.000 liter. Find the molar concentration of the final diluted solution. If questions comes like this, to solve it, you use your formula M1V1 MFVF or MIVI is equal to MFVF, or M1V1 is equal to M2V2. The initial molarity or concentration is 0.240. The initial volume is 0.200 liter. The final volume is 1.00 liter, and then we are looking for the final molar concentration. So that the final molar concentration, if you have done it this way, you are going to get 0.480 mole per liter. 0.480 mole per liter. So generally, this is how we prepare standard solutions. It is how we prepare standard solutions, and this is how we solve for dilution calculation. Okay, so let's look at some few questions. WAEC 1992, you have to define a standard solution. I have to give reasons why a standard solution of sodium hydroxide cannot be made by weighing out accurately a given mass of the solid and making it up to the required volume of solution. Now let's look at it. You can take time to solve this question yourself. Give me reasons there. Use 1 minute to solve it. Use 1 minute to solve it. Try what is a standard solution and give a reason why a standard solution of sodium hydroxide cannot be made by weighing out accurately a given mass of the solid and making it up to the required volume of solution. If you have done that, this is what you are going to get as your answer. Now, a standard solution is one whose concentration is known, or you can say a standard solution is a solution with a known concentration. A standard solution is a solution with a known concentration. Now, for the second question, note that sodium hydroxide is deliquescent. That means it will absorb moisture from the atmosphere and dissolve in it, and will also absorb that water, CO2, and dissolve in it. So from the atmosphere, when it absorbs moisture, it can add to the weight, hence cannot be used as a primary standard. What we are trying to say is that sodium hydroxide cannot be used as a primary standard. We've informed you know what a primary standard is now, because it is deliquescent. It will accept moisture. If you expose it for a very long time, it will accept moisture or CO2 and dissolve in it, and this will generally add to the weight. That means the weight is not in its original form again. The weight has been tampered with, so we cannot use sodium hydroxide as a primary standard. That's the answer for that question. Now, WAEC 2012 asks a question of what is a primary standard solution. Then you have to calculate the mass of sodium triisocarbonate 4 required to prepare 250 centimeter cube of 0.15 mole per dm cube solution. So you have to a primary standard. If you have done it very well, you should know that the primary standard solution is one whose concentration is known and can be used to standardize another solution. Its concentration is known and can be used to standardize another solution. Or you can also say that a primary standard solution is a solution of no concentration prepared from pure or non-deliquescent or non-hygroscopic substance. It's a solution of no concentration prepared from pure or non-deliquescent or non-hygroscopic substance. Now you are looking for the second question. Now says you have to look for the mass required to prepare 250 centimeter cube of 0.15 molar. Quite simple. The molar mass of Na2CO3 is 106 gram per mole. You can do it directly. You can first find the mole. From here you can find the mole because N is equal to C times V. So but you can convert the V to dm cube. That's 250 over 1000. So that's 0.25 dm cube. So you can see N is equal to 0.15 times 0.25. Then you get your N. Then by getting your N, you can now get your mass by multiplying by the molar mass. That's 106. And then 106 rather. Then you get the mass. If you don't want to do it that way, since our N is equal to concentration times volume, and then our N is equal to mass over molar mass, then by implication
mathematically we can say mass over molar mass is equal to C times V. Then mass therefore can be equal to C times V times molar mass, and that's what we did here. So we can now say mass is equal to C times V times molar mass. So that's 0.15 times 0.25 times 106. That's 3.98 gram. So the mass that will be needed is 3.98 gram. So that's that of preparing standard solutions. So far in this part B, we have looked at how to prepare standard solutions of acids and base, and then we have also looked at how to calculate dilution, dilution factor, and then we have also looked at some questions under standard solutions. I hope you have learned a lot into this class. Take time to solve more questions. Ensure you take time to solve more questions as you see them, and of course, if you have opportunity to prepare standard solutions, please ensure that you follow the required procedure and all what we have mentioned in this video. Continue to learn chemistry, and bye bye for now.